You smell like poo poo. Alright, hello everyone, welcome to another video. In this video, we're going to be creating our basic calculator program in Python, and what I'm going to show you is my Visual Studio Code setup. As you can see, I only have two extensions installed, nothing related with Python. I just have a database viewer and a markdown viewer that's going to be helping us later on, and it's going to continuously recommend that, hey, you should download this extension. At this point, we don't really need it. Yes, you can use it in the future for sure, but personally, it's going to do a lot of the things that we don't really need to do right now. That's going to get in the way of you being a basic programmer. So what we want to do is just really keep it simple. We don't want to add anything new, and we just want to learn how to write code in Python, and so that we can write Python-based programs. So what I want you to do is we're going to click open the folder. So when you open up your Visual Studio Code for the first time, you're going to get this welcome page. And if you don't want to see that anymore, you can just toggle that off at the bottom. All right, so what we're going to do is open folder. And what I like to do is under my user account, I like to create a folder for code. And I really recommend that you do that, right? Most of the time when we do work in our terminal and go to our home, it's going to go to this section here. So when we do navigate to home through our terminal, we can have a one designated folder where it contains your code. Now, some naming tips: stop adding spaces, stop adding special characters, right? And obviously when you're coding, to be honest, like, don't use uppercase letters when you're naming your files and directories unless it specifies you to do that, because when we start navigating your directory names through the terminal, it's going to get very annoying when you have long names. As you can see, like my coding folder, it just is called the code, right? And what I've done is, well, I've done coding in the past, so I do have a lot of codes here. But what I've done is that I've created this new folder called IBCS, and that's the folder that I'll be working out of for these types of tutorials. So what I want you to do is, on your user, right, create a new folder, create a new directory called code, and you can create another folder if you want to store all these early tutorials, and then you can create folders later, and then you can do your projects there as well. All right, so we're going to call IBCS right there, and that's what I did. All right, Mac user, same thing. If you have enabled home button, from the home button, create a new folder called code, and you should code out of that. And I'm going to be selecting this folder, and then what I should have is I can get rid of this welcome time, and right now my Explorer has this directory open. And what I'm going to do is create a calculator.py Python file. And, you know, before we do anything, what I want to do is open up a new terminal as well, which I have on the side. All right. So basically, we're going to be editing code here, and then we're going to be executing our Python code here. And if you notice, my terminal is pointed towards the directory where my calculator.py exists. Okay, so terminal is our I guess command-based user interface where we write coding like instructions single line at a time, and we get to execute programs from this terminal, right? We're not going to create GUIs yet. We don't even know how to program in Python really that well yet, so we're going to write some very simple line by line scripts, and then we're going to be executing and writing a terminal based program right here. So for example, if I want to write a very basic code, I can ask Python to say hello world. So I've saved it. If I do ls, as in, if I do ls, I can list out everything that exists on my directory from the terminal, right? So we're really not going to be dealing with us interacting with something like this. We don't care about this anymore. We're going to be dealing with our computer from the terminal. ls, right? For example, if I wanted to make a new directory called new, right, in my hard drive now, within this folder called IBCS, I've created a new folder called new, right? And I can do remove -r new, and that's going to get remove my directory because, you know, I removed it. I didn't need it. So let's clear that and list out all my code, list out all my programs and files on that directory. Now I just have my calculator.py. Whoa, so now you're wondering, well, now this is not like Replit. This is nothing like anything I've done before. There is no run button and whatnot, right? Well, that's okay because we installed Python. We're going to ask Python. And if you're using Mac, you're going to write Python 3, right? But you're not, since I'm on Windows machine, I'm going to write Python. If you're on Mac, you're going to write Python 3 if you have installed Python properly. So I'm going to ask Python, hey, in this folder, I have a Python program called calculator.py. .py tells me that this is a Python script, and I just simply press enter and it executes all the code. So basically, the Python interpreter is going from line 1 and 2. Line 1 is like, oh, that's a comment. We don't really do anything, and we go to line 2 and it executes what we wrote. We're asking, hey, Python, you have a built-in function called print, and what print does is takes whatever string data or textual data we write in here that are trapped in proper quotation marks, it's going to bring it to our terminal. So I can say that, oh, hello class, you smell like poo-poo, right? You can literally write any textual data if you want, and it will output that code for you because I'm running this Python code that has one single line of script that says, or a code that says print hello class, you smell like poo-poo. Okay. So our program goal is to build a simple Python program that can add, subtract, multiply, and divide two numbers. Okay, and then let's do some functional decomposition here. All right, we're going to break down this very, very difficult problem, and we need to think about what we want to do. All right, so we want to build a simple Python program that can add, subtract, multiply, and divide two numbers. Well, it seems like I need to obtain a way to grab two numbers, obtain a way to choose either add, subtract, multiply, and divide. Right? We need a way to choose add, subtract, multiply, or divide. Then what we need to figure out is do the wanted calculation with the given two numbers, output the calculation / result. That's what we're going to do. At the very essence of this program, what we did was we have this statement. We have our program goal, and we just did a very simplistic functional decomposition, thinking about what are my requirements, what are my basic requirements to do this, to create this program. Okay, so I'm going to label this as 1, 2, 3, and 4. Right. Well, we just learned that, well, to create this interactive program where we can see data that's coming out here, right, we can write messages by using this function called print. And it's very simple. We don't need to import anything like Java. We can just write the word print, and we can say, hey, welcome to our calculator app. Okay, let's run that. Okay, I'm going to clear my console by writing clear, right? See, if I write clear again, everything clears out. I'm going to ask, hey, Python, here, run the calculator, our newly saved calculator. By the way, after you make an edit, hit Control S or Command S if you're on Mac, right? Because it doesn't autosave. All right. It says, welcome to our calculator app, and it finished, right? Our interpreter has completed reading all the lines in our Python code, and it has successfully executed every single line, right? And if I wrote some gibberish, what it's going to do is the interpreter is going to get mad at me. We're going to get a syntax error or name error. And it says this is not defined. It has no idea what that is because we did not do anything that is following the syntax and the semantics of Python. So you don't want to do stuff like that. You want to follow the syntax and semantics of Python so that you don't get error lines like so. Awesome. All right. What we want to do is now input or grab two numbers, and that's very simple. There's a function called input. So anytime we need data, we create data and whatnot, it needs to be stored. It needs to be stored in a variable. All right. So let's do our step number 1 here. Creating another thing, obtain a way to grab two numbers. And we can do this by using the function called input, and we can also create variables. So we're going to have this variable called num1. Whenever we name variables, doesn't start with capitals, can't have special characters, and we're going to follow meaningful naming conventions. We're going to make sure that when we create a variable name, it's not going to be ambiguous, but it's not going to be too long where it's impossible to read and write, but it's going to be short and reflective of what we're going to have. Therefore, I have num1. This is my very first number that we're getting. It's going to be assigned to. Notice the word that I used. I didn't say equal to. I said num1. This variable is assigned to. Okay, there's a big difference here. Okay, I'm saying num1 is being assigned to a value, not equivalent to a value. Okay, because when we talk about equivalent, we're comparing two values, but that's not what we want to do. It's not math class. Here we're saying num1 is being assigned to some sort of a value. And luckily for us, this function called input is able to generate and grab whatever we type in our terminal. And inside we can write our instruction, right? Enter the first number. Okay, let's see what happens. We're gonna clear our screen. We're gonna write Python. We're gonna execute our calculator py. Right? It says welcome to our calculator app, and then it outputted this message here. Look at that. That's what the input function does. We write the name of our function, and inside the argument space, we provide a text. Right? We're not literally inputting stuff in here. All right. This is the instruction set our Python code is following. And what we've told is the following. On line number 9, we told Python, hey, print this message. Okay. And on line 12, there are multitude of things happening. On line number 12, the interpreter will realize that, hey, I've created a variable called num1. It will be assigned to the result of this function completing. The function is not completed yet, right? This program right here is still running. It's still waiting for me to write input. Okay. But it says here, enter the first number. Whatever message, whatever string text message I write within those bracket is going to be printed right here. It's going to be outputted right here. So this is not where we input values. This is where we write the instruction when people interact with our code so that they know what I am inputting, what I'm typing on the terminal. Okay. Because we do not interact with the code within the editing space. We interact with the code in the terminal space where we're actually interacting with the creations that you made, right? So we call that a prompt. We're giving them a prompt of what they should be writing, and hopefully they write stuff like this. But right now our program is not that smart, so I can write poopoo and pp, and it will still work perfectly fine. All right. But we have figured out a way to input something. Well, how do you know if num1 actually holds the values that we inputted? Well, we can test it, right? Test num1. Well, how do we check what that value is? You just use another print statement, and we can write num1 is, and we comma num1. Save that code, run your code again, and I can say num1 is poopoo. It's gonna output poopoo. If I say num1 is 420, it's 420. Okay, so whatever value we typed in here, when we interact with the terminal, when we have been given this instruction set of enter the first number, whatever value we press type, and after we press enter, right, it's going to be assigned to the variable num1, and that's what we have. All right, cool. With that same logic, we need to grab two numbers. We're going to go num2, input, enter the second number. And now we have two variables that we can use to add, subtract, multiply, and divide. All right. Now we're going to see some interesting behavior. Now we're going to say obtain a way to choose add, subtract, multiply, and divide. Awesome. All right. We need a way to choose. Well, let's create that as a variable called choice, and we're going to ask them to input. Choose either add, subtract, multiply, or divide. Like that. Boom. Now if I save that code and execute, it's going to do the following. Welcome to our calculator app. So it's finished this, and now it's hanging on to line number 12. Notice the interpreter has not gone towards line 13, 14, 15, 16, 17. While I am talking right now, our poor program is waiting for us to give a value, give an input, asking for this input function to finish its life purpose, okay, which is to grab written keyboard inputted data within the terminal, okay. And it was so nice. It has given us a prompt, enter the first number, but this teacher, this butthole of a teacher, is not writing anything down, so her Python file's stuck. It is waiting and waiting until I, do Control Alt Delete and shut down this program, or it's going to be stuck on that instruction. It's going to be, the interpreter is going to be stuck on this line and can't do the rest of the code, because programming and code instructions are all about executing your code from top to bottom. So we have enter the first number. We want to give it, let's say, 10. The second number, 2. And then our next set of input is choose either add, subtract, multiply, or divide. And we're going to say, hey, well, we want to add. Perfect. I'm just going to get rid of that space there. All right. Now we have ability to choose either add, subtract, multiply, or divide. And we were able to grab two numbers. In our functional decomposition, where we only decomposed 4 times, we did the full 2 half, or we did the half of what we needed to do. We almost have a complete program. So in our third section is what we want to do the wanted calculation. So complete the wanted calculation. Well, the crazy thing here is that we have 4 pathways. And in class, we learned that, hey, pathways, decision making, choose, that its concept is called branching. And when we want to do branching, we want to make conditions. If something's true, do this. If other thing is true, do that. And we do that with if statements here. We're going to say if. Okay. We're going to compare the value that is stored in the variable called choice and is equivalent to, see, notice I'm using the word equivalent here. Right? I said num1 is assigned to this result. Choice is assigned to this result. But as soon as I use to equal sign, now I'm asking if choice is equivalent to the value on the right. Well, what is it equivalent to? Add. Right? Then we made a choice. We chose to add the 2 numbers that we were inputted. Well, what should we do? Then we can say we can do print num1 plus num2. We can do the addition of num1 and num2. Perfect. Let's test that out, right? You don't need to go far. We're coding, like you code a little bit and test it. And if it didn't work, fix that line and retest it and see if it works until you get to a point that you are satisfied and you can move on with your code. Here, we're going to enter number 10. We're going to enter the second number 2. We can choose add, subtract, multiply, divide. I'm going to add because I haven't coded subtract, multiply, divide yet, and I can only test add. We're getting 102. How fun, right? It seems like Python doesn't know. Python doesn't know how to add 10 and 2. Okay. Well, to be honest, it's because we've done everything. We have something called a semantic error happening here. Semantic error happens when really we wrote everything perfectly. There is no error. There is no, we didn't get any syntax wrong. However, Python is executing our code as directly and literally as it's written. Okay. The problem was we're dealing with numbers, but the input function will always assume that whatever we write as inputs are deemed to be strings and text. And if you add 2 texts together, we are just joining them side by side. There is no arithmetic logic when we add text together. So with this input function and input function here, where we want numbers rather than text, what we want to do is after we get the input, we want to trap the number, trap the input, with the result of an int function. We want to convert the input that we got into an integer by running this type conversion function called int. And that's what int does. Okay. So we're going to get some interesting behavior. So for example, if I wrote poopoo now, it's going to get an error because I can't convert poopoo. There is no number called poopoo in our base 10 system. So it literally says value error. I have no idea how to convert poopoo to base 10. But if I rerun this code and give it our starting value of 10, none of the errors occur. If I give it the value of 2, no errors occur. And I can still write add. And since choice was equivalent to add, this branch here that we created was true. And we were able to add num1 and num2 together to get a result of 12. If I were to run the same code with our same input, but I wanted to subtract, that makes this branch condition false. So this print statement doesn't occur because this block of code that belongs to this if statement only gets executed if this Boolean statement, if this comparison was true, as only if choice is equivalent to add. So you could be saying, well, let's just write if choice is equal to subtract. Let's write print num1 minus num2. Let's code that. And to be honest, you got it 99% right. We can do 10, 2, we can do subtract, and it's going to give us 8. Now, this is where I want to talk about related conditions and unrelated condition. When we have an if and an if here, okay? When we have an if and an if, we are saying these two branches are not related to each other. We will check this condition no matter what, even if choice was equivalent to add, right? We have this one variable that creates 4 possible branches of add, subtract, multiply, divide, and there is a 5th one, but I do want you to think about that a little later on. But there is 4 main branches that we do want to create from this variable choice: add, subtract, multiply, or divide. But when we write that if choice is equal to add, we're going to do this, and if choice is equal to subtract, we're going to do that. They are unrelated because when you start a new if statement, it does not care about the previous if statements. Python interprets that as, oh, the previous conditional branches are all done. Now this is a totally unrelated branch and we're starting new branches. All right. So, for example, if I wrote an else here, print invalid operation, right? If I wrote that, hey, if this is false and all else, run this code, we can do something like this. We could say 10 to subtract. It's going to output, hey, invalid operation, but still go into this line number 24 saying if choice is equal to subtract, though, you're going to do this. Okay. This is where this if is totally unrelated to this first if statement here. We've created 2 separate branches, but what we want is from this variable, we want to create 4 branches, and that's when we use this connected if statement called elif. We want to say if my prior if statement was false, but I still need to check a condition. All right, I'm going to say that again. We use an elif if the connected if statement, the if statement I'm connected to, is false, but I still have another choice or a condition to check over. That's when we use an elif. Because in the previous statement, if I used an else, this occurs when all the related conditions related to else is false. So when this was false, we just automatically went here. But we do still need to check if it's either subtract, multiply, or divide at this point. So we're going to write elif, choice is equivalent to subtract. We're going to print num minus num2. And then we're going to do elif. We're going to do choice is equal to multiply. And we're going to say print num1 multiply by num2. And then we're going to do elif if choice is equal to divide. We're going to do print num1 times num1 divided by num2. And there we go. Let's test our code. We have added all of our calculations, and then we also did our output the calculation all at once. We'll be optimizing this code in a bit, but let's execute our code now. First number 10, second number 2. Let's try multiplying. Our expected value should be 20. So if we were doing a unit test and a positive test, we gave 2 positive values, and then we should be expecting 20, and we're expecting 20. So this was our very first run through of our calculator app. Our goal was to build a simple Python program that can add, subtract, multiply, divide 2 numbers. And what we did was a little easy functional decomposition. We obtained a way to grab 2 numbers. We obtained a way to choose either add, subtract, multiply, and divide. And we did the want to calculation, and we output the calculation. Now, with this code, there are a lot of errors there are a lot of potential errors, and there are a lot of things that we should actually consider to make this program more viable. But this is what we call a minimal viable product. We weren't really worried about any weaknesses in our program, but rather get something working so that we can improve upon it and optimize it as we go. All right, so that was that. Stay tuned for the updated version of the calculator video in a bit. And as always, thank you for watching and stay classy.